Imagine your heart stopping. You close your eyes and feel life ending. But when you wake up, a brand new, perfectly healthy heart is beating in your chest. Moreover, this heart wasn't taken from a donor or someone who died in an accident. Doctors produced this heart from scratch just for you, in a massive printer right next to the operating room. Scientists are no longer just producing plastic, metal, or toys in three-dimensional printers. They are trying to produce tissue directly with living cells and blood vessels. So, is this just a science fiction fantasy, or could an organ coming out of a three-dimensional printer truly be implanted into a human body and function one day? For the first time, humanity is trying not just to heal its body, but literally to reproduce it from scratch. Is the era of artificial organs truly beginning? Today, we are taking a closer look at the biggest and most incredible revolution in the medical world: bioprinting technology. To understand this crazy idea, we must first clarify the concepts. When most people hear artificial organ, they imagine robotic, battery-powered, or plastic parts. In the medical world, there are different levels of artificial organs. The first level consists of mechanical heart devices that pump blood or titanium prosthetics. These are entirely mechanical. The second level is bioartificial organs, which are systems where living cells are placed inside devices. However, the true hero of our video today, the third level, is very different. Three-dimensional bioprinting. At this level, there is no metal or plastic. This technology uses living cells directly to rebuild a human organ from top to bottom, layer by layer, in a completely biological way. The answer is, unfortunately, very painful and very simple. To survive, today, hundreds of thousands of people worldwide are in a desperate wait on organ transplant lists due to organ failure. And the bitter truth is that every day, dozens of people lose their lives on those lists because a suitable heart, liver, or kidney cannot be found for them. Organ donation can never meet the demand. Let's say you were lucky and a suitable organ was found. The battle doesn't end there. There is always the risk that your body will perceive that organ from a stranger as an enemy, reject it, and attack it. You have to use heavy immunosuppressant drugs for the rest of your life. Bioprinting technology is not just a cool technological curiosity. It is literally the last line of hope between death and life for all these patients waiting for organs. So, how exactly does this system work in the laboratory? Think of the normal three-dimensional printers we use in our homes or offices. You give these printers a plastic or metal raw material, and they melt that plastic to produce toys or tools layer by layer. The mechanical logic of bioprinters is very similar to this. However, they do not contain plastic, but a very special raw material. Bioink. This ink consists of a combination of a liquid-like support material called hydrogel and living cells. As the printer's massive needle moves up and down, it stacks the cells on top of each other according to the organ drawing it receives from the computer. As each layer dries or hardens with special lights, a three-dimensional biological tissue, a structure, emerges. Here, we must ask the question that is asked most often and surprises people the most. To whom do the cells inside that bioink placed in the printer belong? Are they taken from another living being? This is where the true miracle of the technology begins. Those cells can be taken directly from your own body. Simple cells taken from the patient's own skin or fat are passed through special processes in the laboratory and converted into joker cells called stem cells. Stem cells are miraculous keys with the ability to transform into any type of organ cell in the body. Then, these cells are placed into the printer and printed to create a new organ carrying your genetics. The greatest advantage this technology offers to the medical world is perfect compatibility. Since the heart, kidney, or liver coming out of the printer is produced directly with your own deoxyribonucleic acid code in your own cells, your immune system does not reject it. Your body does not attack it as a foreign substance. The risk of rejection drops to almost zero. Waiting lists could become history. Instead of waiting years for a compatible donor, patients could walk out of the hospital in just a few weeks with a personalized organ printed for them. If such a technology exists and has been researched for years, why do we still not see these printers in hospital rooms? Why do patients still continue to die? This point is the most critical balance point of the video. Because printing an organ does not just mean copying the outer shape of that organ exactly like a plastic statue. The human heart is not just a pump made of meat that looks like a heart. Inside that heart, there are microscopic vessel networks kilometers long, nerve systems, continuous chemical communications, and oxygen transport. Printing a heart or liver shape might be easy. However, Keeping that printed shape alive and making it a functioning organ is the most difficult engineering problem in human history. The biggest wall scientists hit in laboratories is the problem of vascularization, meaning the formation of vessels. For large tissues and organs in our body to live, it is not enough for cells to just stand side by side. Oxygen must constantly reach those cells, nutrients must be transported, and the waste produced by the cells must be removed from there. The only thing that provides this is capillary vessel networks that are thinner than a hair. Scientists can currently print thick vessels with printers. However, it is extremely difficult to print those microscopic capillaries into the organ in a way that prevents the cells from suffocating and dying. An organ without a circulatory system dies by rotting from lack of oxygen a few hours after being printed. For an organ to live, cells are not enough. A perfect highway network is required. As of today, scientists trying to overcome this massive wall have not been able to make an organ large and fully functional enough to be used in hospitals. But they did not give up. Today, incredible things are being produced with three-dimensional bioprinters. Skin tissues and structures like cartilage, which do not need a circulatory system much, can be successfully printed. Even skin can be produced in the laboratory and transplanted for burn patients. More importantly, scientists are successfully printing structures called organoids. Organoids are small and simplified miniature models of real organs, the size of a sesame seed. Heart organoids and brain organoids live and even beat inside tubes in the laboratory. Thanks to these miniature organs, the first revolution of bioprinting technology is happening in laboratories, not in operating rooms. Imagine a tumor organoid being printed from a patient's cancerous cells or a mini heart from their heart. Doctors give the very dangerous or toxic drugs they will give to that patient, not to the patient themselves first, but to that miniature copy coming out of the printer. They test whether the drug works directly on that mini organ. In short, the need for animal experiments is decreasing, and a zero-risk treatment opportunity personalized for each patient is emerging. Let's come to that massive question in the title of the video. Will a fully functional, blood-pumping heart that beats in our chest truly be able to be printed one day? Theoretically and biologically, there are no physical obstacles in front of this. Yes, it might be possible. Thanks to the combination of artificial intelligence and bioprinting technology, scientists have already begun to map those complex vessel networks. However, we must be realistic. Billions of cells living perfectly at the same time, beating with electrical synchronization, and vessel networks working for years without clogging is still a very large engineering problem that needs to be solved. So, there is probably still a long road of decades ahead of us. While bioprinting technology progresses slowly in laboratories, another race has started that dropped like a bomb on the medical world's agenda. Xenotransplantation, meaning organ transplantation between different species. In recent years, scientists have succeeded in transplanting the hearts and kidneys of specially genetically modified pigs into humans. These pigs were specially designed so that the human immune system would not attack them. In the future, hospitals will come to a turning point. On one side, completely clean but very difficult to print artificial organs coming out of three-dimensional printers with human cells. On the other side, genetically modified animals raised on farms to produce organs for humans. The medical world will enter a great moral and scientific race between these two technologies. The issue is not limited to just the technical or engineering dimension. When we have such great power over the human body, we will face very heavy ethical questions. In the future, will three-dimensional organ production turn into a billion-dollar commercial sector? Are we entering an era where we choose organs from a hospital menu? Since this technology will be incredibly expensive, will a terrible inequality begin where only the rich can buy spare organs while the poor die of organ failure? The most frightening question is this: will the human body turn into a machine, a spare part system, where we can order a broken part and replace it with a new one? Where does the limit of our humanity end? If we overcome all these problems and standardize this technology, the scenario of extending human life will inevitably confront us. If diseases like heart attacks, liver, or kidney failure, which are a very large part of the causes of death, become history, could the 80-year human lifespan increase to 150 years? It certainly could. However, we must emphasize a very important fact here. Living long and living healthy are not always the same thing. You can change your organs and keep your heart young, but you cannot solve the aging of your brain and diseases like Alzheimer's just by changing organs. In other words, even if you repair your body like a robot, it is still an unknown mystery how healthy your mind will remain in that body. In conclusion, when we look at all the laboratory research, stem cells, and massive printers, we realize that we are at one of the greatest breaking points in human history. Perhaps in the hospitals of the future, patients will not wait for an organ to arrive in the emergency room. That organ will be produced in a printer in a laboratory according to the patient's genetics. For the first time, humanity is not trying to heal diseases with external drugs, but to reproduce its own body at a molecular level. That great revolution where organ donation campaigns will completely become history is perhaps much closer than we think. So, what do you think about this? Even if it would save your life, would you accept a heart coming out of a three-dimensional printer in a laboratory beating in your chest? Or do you believe this technology will turn humanity into an irreversible, frightening robot? Share your thoughts and concerns with us in the comments. Don't forget to subscribe to the channel and turn on notifications to continue discovering the secrets of the future in science.